Thanks, Nick, for the intro. And yeah, we're going to jump right in here and talk about introspecting your machine or other machines that you're responsible for using osquery. Slides, anytime you see a highlight in the slide, that is a link. There is a link on this first slide. You will want to take a look at this slide deck, which is already available, because a lot of the resources in here, well, there's a lot you can't fit into a 20-minute presentation about a tool that can do as much as this one can. So, what osquery does is it exposes a whole bunch of your system's behaviors, a whole bunch of system configuration, hardware, software, networking, et cetera, all via SQL, specifically SQLite. You can do joins, you can do selects, and all of that parsing of config files, system APIs, et cetera. Heck, you can even curl web requests. Well, it's not using curl under the hood, but you can make web requests through SQL on your system if you so desire. A lot of this is around like system admin stuff, IT management, et cetera, but there are some fun things that you can do, for example, threat hunting and such. One of the things you can do there is figure out whether I'm, for example, running Apple Intelligence on this machine, or alternately, we can grab this query right here, pop it into the terminal, make sure I am, come on. Okay, that is, and this, and I'm getting, actually, let's make that better. So, all of the open files on this system that have processes open that are below 100 kilobytes in size, I just grab the SHA-1 hashes of all of them, just with one simple SQL query rather than having to write some script that I have no clue how to write. So, with that demo out of the way, the reason for osquery's existence was back in 2014, Facebook had a problem, specifically their sysadmins and their security team. That problem was that the existing tooling around figuring out the bunch of data from a bunch of different data sources on systems that they admin, whether that's corporate machines or whether that is stuff in their data centers, that tooling was fragmented, and you had to pull from a bunch of APIs or files or what have you, and then parse those out and write scripting around that. And the tooling just kind of wasn't there for particularly Mac OS and Linux. And even if the tooling was there, it was kind of a black box. You couldn't really see what made it tick, and if there was some issue with that parsing for some reason, then you couldn't necessarily fix it. So in 2014, Facebook released osquery, which the point there was to expose all of this disparate configuration information in a bunch of SQL tables and then kind of allowing you to take it from there. In 2016, they added Windows support because, well, for one, the Windows ecosystem around this had been a little bit better, and for two, people wanted a cross-platform tool. In 2019, that tool got handed over to the Linux Foundation with a kind of sub-foundation of its own. So at this point, osquery has kind of taken on a life of its own with a bunch of contributors from the community. Now, why am I up here talking about this? Well, the place that I started working back in August, we use osquery heavily for what we're doing, which is device management, some security stuff there, vulnerability management as well. And we pull information from Mac OS, Windows, Linux machines via osquery. And kind of our genesis as a company, well, one of the co-founders was one of the original folks on the osquery project. And as the project went from a Facebook thing to a Linux Foundation thing, he is now on the technical steering committee. Now, like, we, as a company, as Fleet, contribute back to osquery on a regular basis because there's stuff that we need that isn't necessarily in there yet, fair amount of Windows stuff. Those contributors, there's one or two on each of our couple of dev teams. I am not one of them because I, for some reason, like writing Go rather than writing C++. But there are other folks on my team that have actually done contributions back to osquery. With that said, that's about all I'm going to say about where I work. This is an osquery talk, not a vendor pitch. So, show of hands. Who of y'all have heard of osquery before? How many of y'all have used it? And how many of y'all would you say are more on the security side, whether that's red team or blue team? And show of hands, how many of y'all are pretty comfortable doing SQL queries rather than, say something else? All right, so kind of with that aside, let's go back to what we're actually going to talk about in this presentation. And first off, I'm going to go through kind of what the kind of core goals of osquery are, go through all the tons of things that you can pull via osquery tables, and I'll look at some caveats and tips along the way of like, hey, there are certain pieces of this open source tool that you might trip over. Let me save you a bit of time around those. And then lastly, if we have time, we'll take a look at a few little bits of threat hunting of, hey, if I have a infected machine or a machine that I think might have been compromised, how would I use osquery to actually exhibit that? So, first off, osquery was Mac OS and Linux first. Windows support, there are a bunch of Windows-specific tables in osquery. There are a bunch of tables that are cross-platform Mac, Windows, Linux, but Windows support is still a bit hit or miss. That story is improving, but something to keep in mind. The idea here is that instead of writing a whole bunch of bash scripts or using some other tooling to pull information from a machine, everything is an SQL table. Now, that SQL table might be a single row, but at that point, at least you can get it in a consistent interface. And the heavy lifting on that querying and filtering once the data is actually ingested, whether that's real time or via what they call evented tables, which we'll get into later, that is handled by SQLite, not reinventing that wheel, but the actual parsing of the data sources, whether that is system APIs, whether that is files, whether that is even network calls in certain cases, that is all done by osquery. And another really important thing is reliability. This needs to be able to run on either corporate machines without interfering with people's ability to get their jobs done, or in production environments where you really don't want to be handing a bunch of CPU load to your telemetry, because when you're at the scale of Facebook or what have you, that additional load really adds up. So one of the design principles in osquery is it has a worker process as a child of kind of the process that starts in the background or in the foreground in certain cases. That worker process does all the heavy lifting. If that worker process was handed a query that really shouldn't have been initiated, then that worker process might consume a bunch of resources. And then the watchdog process will say, well, you're going away, that process is getting killed, it's going to get respawned, and now that query is going to get deny listed. So you're not causing prolonged system instability because of asking your machine to hash every file on it. And lastly, this is an open source project, whether you want the GPL2 copyleft license or the more permissive Apache 2. It is dual licensed. You can include this build on top of this, as many, many companies have done. So there are a lot of tables built in here, and we'll go through a non-exhaustive list. First off, hardware. There are, well, a bunch of pieces of hardware, each of which have their own little schema, and all of these are on that osquery site, that schema list. You'll notice that the 270 plus tables was highlighted. That is a link to that schema list, which is helpfully on a single page, so you can use Control or Command F to find whatever you're looking for. You'll also notice that the underscore events bit here is highlighted toward the bottom of the left of my slide. That is because there are certain tables that instead of reading data on the fly, you pass a couple of command line flags to either the osquery daemon or to the osquery kind of run in the foreground shell, and it will start collecting data in the background. There is a limit to how much data it stores. That limit is configurable, but the idea there is you have a time-stamped event log that you can kind of query and purge as needed, so you can get historical data rather than point in time. Next, you have software, whether that is Mac OS, Windows, Linux, various flavors of Linux. This, because there are distribution-specific things here, one of the items that I could not fit on this slide was actually portage packages. So if you have Gentoo, you can still figure out what packages are installed via a SQLite table in osquery. But the idea here is, if you have it installed, mostly snap packages aren't on here, unfortunately. If you have it installed, or if you have like apt sources or something like that, you can query that and say, well, what's actually on this system, whether that is Mac OS apps, NPM packages, Python packages, et cetera, et cetera, et cetera. You can see what certificates are being trusted, what's on the keychain, what users are logged in, what SSH keys you have, what authorized hosts you have, what known hosts you have. On disk encryption, there are separate tables for Mac OS and Linux versus Windows. The disk encryption table is for the first two of those, and BitLocker is for Windows. You'll start seeing a pattern that if there are very OS-specific representations of this data, that is going to get a different table. On networking, you can, you have a fair number of different options here. Some of them are OS-specific. Some of them are using not necessarily the most obvious APIs, which has kind of been a deal of somebody wants to add a table to core osquery, and the barrier to getting that actually added is, well, are you willing to wait for the next osquery release and then do a proper amount of testing as well, with osquery releases generally being every couple of months. There are a couple of tables around Wi-Fi there. If you have a Mac OS machine, I believe it may be Mac OS only, you can do a Wi-Fi site survey. However, in newer versions of Mac OS, Apple hides a lot of information from that API because they don't want people to be able to just magically geolocate folks and breach folks' privacy. So I tried the Wi-Fi site survey bit last night and realized that the SSIDs were not listed there. So there are certain caveats to some of these tables where older versions of an OS may have data that newer versions don't, particularly on Apple machines. On firewalls, whether you are using Mac, Windows, or Linux, you have separate tables for those. For processes running, including things like what sockets are open, what files are open, or as well as scheduled tasks, whether that's cron tab, Windows scheduled tasks, or even things like what starts on startup. For logging, you have both your system logs, whether that is the Windows version, the Mac OS version, the Linux version, or even shell history in cases of, it's like, well, I might have a compromised machine. Let's see if there's anything in the shell history saying that somebody was trying to set up a reverse shell or the like. On the file side, there are multiple tables for this and multiple kind of different use cases here. For one, there is the carves table. What that allows you to do is request that osquery pull file data from the machine. This is useful for kind of incident response scenarios. You will need a server somewhere to push those files to, and you have to explicitly turn that on. Then there's the file table that has kind of basic information on files in terms of modified time paths, that sort of thing, and then hash, which actually hashes files. Some of these tables require you to have a where clause on them because of performance impacts. File events, as mentioned earlier, there are event tables where you can see file actions that happened in the past rather than just getting a snapshot in time. If you have containers on your machine, whether those are LXD or Docker, you can get a whole bunch of stats from those. There are multiple tables around that. With Docker, the osquery data puller is expecting the Docker socket to be at your var run Docker sock. If it is not, then you'll want to symlink to it. If you're running in AWS or Azure, you have a couple of tables there as well. And if you need to read configuration, whether that's the Windows registry or Mac OS plists, or even figuring out what kernel modules are enabled, you can do that. And you can even figure out what the system thinks, what time it is, how long it's been up, and the other piece of your uptime of load average. And if that's not enough for you, now this is not a comprehensive list, you have what they call automated table creation, which allows you to pull in other SQLite databases, which a lot of things like, for example, Chrome will put things in SQLite files on disk. You can actually query from those with some additional configuration. And if that's not enough for you, then there's an extension API that runs over Apache Thrift. So you can tell osquery, hey, I'm publishing these tables, and I'll handle pulling the data from wherever I need to pull them, but expose these, allow for joining against them, et cetera. And in the case of where I work, we have another, I think, 30 some odd tables in our agent that are queryable via osquery. So the idea here is to get all of this data available. This is not necessarily a super consistent interface, but you can put layers on top of this. So I realize I'm running a bit short on time here, but if a lot of table or a number of tables will have kind of scoping built in, whether you're running this as root, whether you're running this as a user. If you're running it as a daemon, you're probably running it as root. If you're running it as root and you look at Chrome extensions, hopefully you don't have your Chrome browser installed as root. So in those cases, you'll want to do a cross join with the users table and say, like, actually get me not only the Chrome pieces for root, which there shouldn't be any, but also the Chrome extensions for any user on this machine, and it will actually do the right thing there. There are certain cases where you can query, you'll get a partial result set. If you join against users, you'll get the fuller thing. Additionally, there are a number of things where the where clause is either required or the query is a bit more performant with the where clause, so keep that in mind. Again, these slides will be available later. On file pass, a single % is going to get you one level of directory traversal, double % gets you recursive. If you want to display results, you'll notice earlier when I did my quick demo, I did a little dot mode line instead of getting your massive SQL pretty printed table. And if you're using things at the command line, you can then pipe those results in whatever easy to parse format. For example, JSON, pipe those to JQ or pipe those to another script that can read JSON or CSVs. Now, if you're running this as a daemon, These results can be pushed to a log, either as a snapshot of the entire query or as a diff of what changed from the previous query run. These can also be piped over TLS to some aggregation server, including information on which host was piping it there. Now, if you have a system that you think might be compromised, you can do things like seeing what processes are on the system, whether those processes are on disk or whether they are only in memory, what sockets those processes have open, what connections to outside that those processes have, and I believe like 2 slides away from ending here, sorry. And finally, what files exist on the system in terms of indicators of compromise. There are a number of resources that I have here in terms of pre-built osquery queries that say, hey, here is an example of finding bad files on the system or finding connections that really shouldn't be there. With that, thank you for humoring me as I walk through a lightning tour of all the things that osquery can do. If you have questions, find me after this. And also, I would encourage you to hop on to where these slides are because, again, all the highlighted stuff is a bunch of links. You will want to hop on those for additional information. Thanks, and have a wonderful rest of your conference.
Awesome.
Woo!